So what did we see in the interference of two waves? Y1 is equal to A sin omega t So y is equal to A sin omega t, or y1 or A1 sin omega t. Y2 will be A2 sin of omega t plus phi. So y is equal to y1 plus y2. So y will be equal to A1 sin omega t plus A2 sin of omega t plus phi. Is that right? So you will have A1 sin omega t plus A2 into sin omega t cos phi plus cos omega t sin phi. Is that clear? So then what will you have? You will have sin omega t into A1 plus A2 cos phi plus cos omega t into A2 sin phi. So A1 plus A2 cos phi, what did we take it as? You took it as A cos theta, and A2 sin phi we took it as A sin theta. Right? Now, A1 plus A2 the whole square will be equal to A square cos square theta, and A1 plus A2 cos phi will be equal to A square cos square theta, and A2 sin phi will be equal to A square sin square theta. So then you had A1 square plus A2 square cos square phi plus 2 times A1 A2 cos phi is equal to A square cos square, okay, plus A2 square sin square phi will be equal to A square cos square theta plus A square sin square theta. So what will you have in this case? You will have A1 square plus A2 square plus 2 times A1 A2 cos phi is equal to A square into cos square theta plus sin square theta, which is 1. So you will have A is equal to root of A1 square plus A2 square plus 2 times A1 A2 cos phi. Is that clear? Then what did we see? You have to. So phi is equal to 2n plus 1 into pi for destructive interference, and phi is equal to 2n pi for constructive interference. Okay. So this we have already discussed, and these 2 points are to be remembered. Okay. The next point that we need to discuss is relation between path difference and phase difference. So relation between path difference and phase difference. Okay. So if I look at a wave like this, if I call this as x and y, between these 2 points, if you observe, the distance is 1 wavelength. So 1 wavelength corresponds to 2 pi radian. Right? So if I take the phase difference between any 2 points as phi, okay, and let's say the path difference corresponds to p, then path difference will be equivalent to phi radian. Is that clear? So which implies phi into lambda is equal to 2 pi into p, which implies p is equal to phi divided by 2 pi into lambda. So this is the relation between path difference and phase difference. The relation between path difference and the phase difference. So what I'm trying to tell you here is phi is equal to 2n plus 1 into pi for constructive interference. So what will be the corresponding path difference? P will be equal to 2n plus 1 into pi divided by 2 pi into lambda. So 2 and 2 will get cancelled. Sorry, pi and pi will get cancelled. So you'll have 2n plus 1 into lambda divided by 2. So when you're trying to answer in terms of phase difference, you should write 2n plus 1 pi. When you're trying to answer in terms of path difference, you write it as 2n plus 1 lambda by 2. Is that clear? So similarly, find what should be the condition for constructive difference. So what are the condition for constructive interference? Pi is 2 and pi. So what will be the path difference? 2 and pi divided by pi, 2 pi, 2 pi into lambda, 2 pi and 2 pi are gone, you will have n lambda. Is that clear? Now the next question is, okay, we have found this constructive and destructive interference thing, fine. But this is a theoretical part which we will try to apply it to an experiment. Like when I discussed yesterday, I told you there was an experiment done by a scientist. What is the name of the scientist? Any idea? So there is a concept called as one minute. Oscar. Oscar. August 14. Okay, sorry. So now we'll discuss about the concept of Young's double slit experiment. So write down the heading as Young's double slit experiment. I'll do one thing. I'll take an empty slide and write it. So write down the heading as Young's double slit experiment. Suppose, so yesterday I showed you a simulation, right, where you had two openings, right? This is slit 1, this is slit 2. And there is a screen present here, where on the screen, light going and falling. Okay. And let's say there is a point P where you are interested to find out whether you have a bright fringe or a dark fringe at the position. So for that, what we will do is, we will do a small construction. Let me call this point as O. Let me call this distance as capital D. Okay. From here I'm dropping a perpendicular, here I'm dropping a perpendicular. Let me call this distance as Y. Let me call this distance as small d. Okay. Then how much will this distance be? It will be d by 2, and this distance will also be d by 2. Okay. Then how much is this distance? It will be y minus d by 2. And how much will this distance be? It will be y plus d by 2. Okay. Okay. Now listen. If I take this point C and point as B, then I'm able to find two right angle triangles, S1 AP, where AP is y minus d by 2, and this distance is capital D. Okay. So what is S1P? Or I will say S1P square, y minus d by 2 the whole square plus capital D square. So let this be equation number 1. Okay. Similarly, if I take S2P and this is B, this distance will be capital D, and this distance will be y plus d by 2. Then what is S2P square? It will be d square plus y plus d by 2 the whole square. Is it right? So what I'm going to do now is, I will try to find out what is S2P minus S1P, because if I observe, I'm able to see that the rate which has gone from S2 has traveled a longer distance compared to the rate from S1. So if I'm able to find what is S2P minus S1P, 1 minute. Proceed. Listen. If I find S2P minus S1P, right, then this will be the path difference. Because if you observe the diagram, right, S2, the ray from S2 has traveled a longer distance compared to the ray from S1. Is it right? So S2P minus S1P, I'll call it as the path difference. So for that, what I will do is I'll consider S2P square minus S1P square. So when I do that, this I can write it as S2P minus S1P into S2P plus S1P. Can I do this? But what is S2P square minus S1P square? S2P square is D square plus Y plus D by 2 the whole square. So D square plus Y plus D by 2 the whole square minus D square minus Y plus D by 2 the whole square. So D square and D square are gone. Y plus D by 2 the whole square minus Y minus D by 2 the whole square is equal to ಇದು ಪ್ಲಸ್ ಇಲ್ಲ ಇದು ಮೈನಸ್ ಪ್ಲಸ್ ಕೊಡ್ತೇನೆ ಓ ಹಿಂಗೆ ಮೈನಸ್ ಬರುತ್ತೆ ಓಕೆ ಕರೆಕ್ಟಾ so it will be 4 times y into d by 2. This and this will get cancelled. You will have 2 times y into d. Are you able to understand this? So 2 times y into d is going to be the path difference. Okay. Now see, we know that path difference is equal to n lambda for constructive interference. So what is the path difference? 2 times y into d should be equal to n lambda. Wait. What did I do? I'm really sorry. Wait. Sorry, correct. Last right side I should have made a change. Y plus d by 2 the whole square minus y minus d by 2 the whole square. D square cancel it. You have it in mind. The d square is gone. So you have 4 times y into d by 2, which is 2 into y into d. This is the LHS. Right. So on the LHS, you have 2 times y into d is equal to, what is S2p minus S1p? That is the path difference into What is S2P plus S1P? This is where we need to be careful. Remember, I'm going to do a small approximation here. The point P is assumed to be close to the center in such a way that S2P and S1P are approximately equal to D, capital D. They will be in such a way that S2P is approximated to S1P is approximated to capital D. Why we are doing this is because when you try to calculate the path difference, they are in terms of few angstrom, because wavelength of light is in terms of angstrom or nanometer. So they are approximated to which value? Capital D. So when you do this, what you will get is, in the place of S2P plus S1P, I can write it as 2 times D. So 2 and 2 will get cancelled, which implies path difference will be equal to Y into D divided by capital D. Is that clear? Now what I'll do is I'll mark it as star. Sorry. Is it clear to this? Now see. For constructive interference, path difference should be n lambda. But what is the path difference we derived now? Y into small d divided by capital D is n lambda, which implies Y is equal to n lambda into capital D divided by small d, where n is an integer. Sorry, I'll write this as Ym. The meaning of this is n is equal to 0. What will I get? Y naught will be 0, which implies this is a point where bright fringes observed. So this is central point. Means if you observe on the screen, this is a point where you will have a bright fringe. Similarly, n is equal to 1, it will be y1 is equal to lambda into capital D divided by D, which is also a bright fringe. So if you observe, what is going to be the difference between these two fringes? The difference between these two fringes will be lambda into D divided by small d. And this distance is called as fringe width. Because right there will be still what you're doing, wherever the first right hand is found, you take that as the sign. Okay, this is point here. Now see, did you write it? Yeah, please write. Yeah, right. Next is for destructive interference. What should I write? Y into small t divided by capital D is equal to 2n plus 1 into lambda divided by 2. Right. So what will be the value of y? Y will be equal to 2n plus 1 into lambda into capital T divided by 2 into small t. Is it right? Correct. Okay. Now the question is, what do I call this distance as? What, like, these are all the points where what is formed? This dark fringes are formed. So what should be the subscript I should write for y? If I write n, okay. If I put n is equal to 1, if I put n is equal to 1, so I should write it as n minus 1. So that if you want the first dark fringe, how much will you put the value as? Put the value as 2. Not need to put the value as 2. புரியுது நான் சொல்றது? Then you should put this as n plus 1. You should put n is equal to, so for you to get that 0, in left hand side, what will you put the value of n as? 0. If you put n as 0 here, you will get y1, that will give you the first dark fringe. So that will be lambda into capital D divided by 2d. Okay, this is one way. See, I told you this 2n plus 1 is there, right? 2n plus 1 is actually an odd multiple. So some books, how they give is, they will give y is equal to 2n minus 1 into lambda into capital T divided by small t. If that is the case, in that case, you can put n as 1. Then you write it as yn. So you need to be very careful in this fact. Because if you read the formula as yn plus 1 for one book, in other book, if you try to validate it, you will not get it. Why I'm telling this point is because sometimes they will mention it like this. When you're using a red light, the fifth bright spot when using red light is matching with the ninth dark spot when using green light. What point is that they're asking? So the bright spot Fourier formula, n lambda into capital T by 2. The dark one there, you will have two structures. What are they? 2n plus 1 into lambda into capital T by T. Are they used pandringa? You can use this or this, not both simultaneously. If you're using the first one, you need to ensure that y has a suffix as n plus 1. If you're using the second one, you need to ensure that y has a suffix of n. Be careful. Right, are you ready to proceed? So I told you about this fringe width, right? So what is fringe width equal to? It is a distance between, or bright fringes. It is a distance between two successive dark or bright fringes. Clear? So now we are ready to solve problems. So Young's double slit experiment is also called as YDS. So in a Young's double slit experiment, the two parallel slits are made 1 millimeter apart. So what is the value given? Small d. So small d is 1 millimeter. Write it down. Or 10 power minus 3 meter. Screen is placed 1 meter away. So d is equal to 1 meter. What is the fringe separation when blue-green light of wavelength 500 nanometer is used? So beta is equal to lambda into capital D by small d. So 500 into 10 power minus 9 into 1 divided by y minus 3. No. Then it should be 5 into 10 power minus 10. No. Lama, 500 into 10 power minus 9 is 5 into 10. Oh, correct, correct. Into 10 power 3. Shall I proceed? Laser light of wavelength 630 nanometer incident on a pair of slits produces an interference pattern in which the bright fringes are separated by 8.1 millimeter. So wavelength is 630 nanometer or 630 into 10 power minus 9 meter. Beta எவ்வளோடா? A second light produces an interference pattern in which the fringes are separated by. So lambda 1, beta 1. Beta 2 எவ்வளோ? 7.2 into 10 power minus 3 meter. Lambda 2 எவ்வளோன்னு கேட்குறோம். So since the setup is same, what will remain constant? Capital D by D is a constant. So beta is directly proportional to lambda. What can I write? Lambda 2 by lambda 1 is equal to beta 2 by beta 1. Lambda 2 out of beta 2 is 7.2 by 8.1 into lambda 1 is 630. Is it? Let me check now. So this will go 9 times, this will go 8 times. 630 nala 70 times, so 560. It is 560 nanometer. Solution is there. Yellow light of wavelength 6000 angstrom produces fringes of width. So lambda is equal to 6000 angstrom produces a fringe width of 8.8 into 10 power minus 3 meter. What will be the fringe width if the light source is replaced by another monochromatic light of wavelength 7500 angstrom and the separation between the slits is doubled? So here, if the slit width is D, beta 2 is equal to how much when D dash is equal to 2D. So what is constant? Capital D is a constant. So apply the formula of beta and so on. 375 by 600. What simplified ratio? 375 by 600. So beta 2 will be 375 by 600 into beta 1. Beta 1 is 0.8. So it will go in 5 as 75, 120. This 5 times pogo, this 8 times. This 0.1, 0.5 mm is the answer. The 0.5 mm the answer. Yeah. Exactly. No approximation. All I do is the final. Those who are online are able to understand?
Yes, sir.
Yes, sir.
Then proceed. Not well? Okay. So let's proceed. In two slit experiment with monochromatic light, fringes are obtained on a screen placed at a distance capital D from the slits. So fringes are obtained when it is placed at a distance capital D from the slit. If the screen is moved 5 into 10 power minus 2, so 5 into 10 power minus 2 towards the slits, the change in fringe width is 3 into 10 power minus 5. Change B2 minus beta 1. So beta 2 minus beta 1, it's not, I don't know which one is greater, so I'm using the word difference. The difference between beta 2 and beta 1 is 3 into 10 power minus 5 meter. If small d is equal to 10 power minus 3, lambda is equal to how much? So beta 2 evado? Lambda into capital D divided by small d minus the same wavelength is used. This time capital D will be d minus 5 into 10 power minus 2 divided by the same small d. So what are you going to take out? Lambda by d, if you take it out, you will be left out with 5 into 10 power minus 2. So lambda evado? Lambda evado? That's what we need to find out. So this is 3 into 10 power minus 5. So this is 10 power minus 3 ஆகும். எதுமா சொல்லுமா 0.6 1 minute, I'll finish this. It is actually 600 nanometer. என்னது புரியல 3/5 is 0.6. Everything else is the multiple of 10, so I just took it to the other side. Let me check if the answer is right. 1 minute. So 6000 correct. 600 nanometer and 6000 angstrom, both are right. Next. Yeah, please. We'll do one last problem. I'm very tired. Fifth hour of class. Continuous. So the break taking from 3 o'clock. Can I proceed? So one last problem, do it. In Young's double slit experiment using light wave of 400 nanometer, interference fringes of width x are obtained. So beta one the x ra. Lambda one is so beta one on the x. Lambda one evlo 400. Okay. The wavelength of light is increased to 600. Increased by kadayadu. So increased to lambda 2 is 600. There is 600. Okay. And the separation between the slits is half. So small d is equal to d by 2. Initially d1 on the d na, d2 will be d by 2. See, whenever you solve a problem based on YDSC, what are the 4 parameters you will have? Lambda, capital D, small d, beta. Okay, in the problem, lambda 1 the 400. So lambda 1 the 400. Beta 1 the x. Lambda 2 600. So I'll tell you a simple method to solve this problem. Now generally I'll follow that. First to put a line like this. Put it like left hand side as beta for 1, right hand side as beta for 2. So lambda 1 400, beta 1 capital X, lambda 2 600. The distance between the slits is half. So d1 d na, d2 is equal to d by 2. If one wants to observe, if one wants the observed fringe width on the screen to be the same in 2 cases, find the ratio of the distance between the screen and the plane of the interfering sources. So D is not changed. Let's check. 3:1. So here it is capital D, here also capital D. So beta they want to be the same. Appa enna solla varam? Lambda into capital D by D, lambda 1 into capital D1 into by D1 should be equal to lambda 2 into capital D2 divided by D2. Lambda 1 evlo? 400 into D divided by D1 is small d. Lambda 2 is 600 into capital D divided by D by 2. D and D got cancelled. Capital D is gone. 2 0 pochu. So this will go to the numerator. It will be 4 is to 12. This is 1 is to 3. So 1 is to 3 or 3 is to 1. So that guy did beta 2 is to beta 1. It's actually the chapter stuff, but you guys are doing it's a lot of stuff. Sense it. Because people won't do it this fast. So on a diffraction, I think I need to explain the detailed theory. That is the only chapter topic finish it. நான் வீடியோ அப்லோட் பண்ணல வீடியோ ஆல்ரெடி வீடியோ கிளியரா இருக்கும் 40 minutes பார்த்தா கிளியரா நான் சொல்லி மறந்துட்டேன் இது அப்லோட் பண்ண That's it. We'll wind up this.
Thank you, sir.
Yeah.